session, we'll see the continuation. The continuation of analysis of buck regulator or step down chopper. In the last session, I calculated these parameters for the maximum inductor current, or the average source current, or the peak to peak value of inductor current. This peak to peak ripple current in inductor that I calculated. Then what is the maximum inductor current? What is the average source current? What is the average switch current, RMS switch current, peak value of switch current, peak voltage across the switch. These parameters I calculated. One point you remember here, I given for the peak to peak value of inductor current, peak to peak inductor current. An extra point you note down here. For the peak to peak inductor current, delta IL equal to, this formula I already given. Peak to peak inductor current equal to D into 1 minus D into VDC by FL. This formula you know. Okay. This you note down in the fourth parameter. Okay. In the fourth parameter, you note down this. Delta IL equal D into 1 minus D into VDC by FL. Now, this peak to peak inductor ripple current. Then the question is asked, at what value of duty cycle ripples are maximum in a buck regulator? Ripples are maximum. Ripples are maximum. Ripples are maximum at a duty cycle of. At a duty cycle of. If it is asked, ripples are maximum at a duty cycle of, it is asked, then d delta IL by dd equal to 0. Differentiate with respect to duty cycle and equate to 0. Then if you differentiate with respect to duty cycle means d by dd of VDC by FL is constant. VDC by FL is constant. D minus D square is equal to 0. 1 minus 2D equal to 0. Then what is D equal to 0.5? That is, ripples are maximum at duty cycle of 0.5. Very important. In a buck converter or step down chopper, ripples are maximum at a duty cycle of 0.5. If the ripples are maximum at a duty cycle of 0.5, then what is the maximum value of ripple current? Then what is the delta IL max? What is that maximum ripple current? Then how to calculate that maximum ripple current means you substitute this condition in the ripple current, then we can get the expression for maximum ripple current. Then 0.5 into, substitute D is 0.5, 0.5 by FL into VDC. That is delta IL max equal to 1 by VDC by 4FL. This is the maximum value of ripple current. These 2 points you note down in. These 2 points you note down in parameter 3. In parameter 4. In buck converter, ripples are maximum at a duty cycle of dash 0.5. What is the maximum value of peak to peak ripple current? VDC by 4FL. Okay, this you know. Okay, quick. Clear? Okay. Now, continue with this. Fifth parameter is completed. Sixth one is also completed. Then you go for seventh one. How to calculate freewheeling diode current? Freewheeling diode current. Is this over? Here, whatever the diode is there, the diode is nothing but a freewheeling diode. Why I am telling that the diode is freewheeling diode means which supplies during the conduction of the diode, which supplies the current within the load only. That I told already. The diode which supplies the current within the load only, that is nothing but a freewheeling diode. The diode which supplies the current to the load through source, that is nothing but a feedback diode. But in buck converter, the diode is nothing but a freewheeling diode because it supplies the current within the load only. Can you find what is the average value of freewheeling diode current, IFD average? In freewheeling diode also, if you neglect the ripples, then this is the, if you neglect the ripple, take the constant current. Here freewheeling diode is conducting. This is dt, this is t. During which time, in freewheeling diode also carries which current? Inductor current. Okay. During which time freewheeling diode is conducting? On time, sorry, off time. During off time freewheeling diode is conducting. That IL into T off by T. That is IL into 1 minus T. But IL is nothing but I0. In buck converter, IL is I0. That is I0 into 1 minus T. Then how to find RMS freewheeling diode current? The RMS value of freewheeling diode current, IFDR equal to, then root of 1 minus D into I0. This RMS freewheeling diode current. This is average freewheeling diode current, RMS freewheeling diode current. Over. This is 7th parameter. Then 8th one. S. In 8th one, you calculate what is the peak to peak capacitor ripple voltage. Peak to peak capacitor ripple voltage. Capacitor ripple voltage. Peak to peak capacitor ripple voltage. How to calculate peak to peak capacitor ripple voltage? We know that Q equal to CV or CVC. But I want change in capacitance. Delta Q equal to C into delta VC. Then what is delta VC equal to? Delta Q by C. Then if you want to find delta Q, what is the delta Q? Change in capacitance you want, sorry, change in charge. How to get this delta Q? Then delta Q is nothing but a area under the current curve gives charge. So many times I told. Area under the current curve gives charge. Na? Why I am telling like this? We know that I equal to dq by dt. Na? I equal to dq by dt. Then what is Q equal to? Integral I dt. Integration is nothing but area. That is area under the current curve gives the charge. Now you take this is the, I want to find what is the area under this current curve. Let this is the, for this I am calculating in T by 2, or you can calculate from this point to this point is also T by 2. Then what is the area under this current curve? Because it is a capacitor current waveform. Area under the current curve, half into what is height? Let this is delta L by 2. Peak to peak is nothing but a delta L. Then what this gives? Delta L by 2. Because in capacitor also inductor current. This is IL, this is minus IL, this is plus IL, means this is IL minima, this is IL maxima you take. Then this gives delta L by 2. And half in height is delta L by 2 into, from this point to this point, this total is T by 4, sorry, T by 2. This is T. This is T by 2 means This is T by 4, this is T by 4. T by 4 plus T by 4 is how much? This is T by 4 and this is T by 4. I am calculating area of this one. Okay. Then what is that time? T by 2. Then what we get? Delta Q equal to delta IL by 8F. 8F. T is written as 1 by F. Delta IL by 8F. What is delta IL, you tell me? Delta Q equal to delta IL is that you calculated already. Delta IL is how much? D into 1 minus D into VDC by D into 1 minus D into VDC by. What is the delta IL you calculated? D into 1 minus D into VDC by, that is delta IL equal to FL. FL means 8 LF square. This is delta Q. Okay. D into 1 minus D into VDC by 8. This is delta Q, but you want to calculate. This is 8 LF square. But what is delta VC equal to? Delta Q by C. That is D into 1 minus D into VDC by 8 LC F square. This is peak to peak capacitor voltage. Peak to peak capacitor voltage. Peak to peak capacitor voltage. Capacitor ripple voltage. Okay, ripple voltage. Tell. Then where this peak to peak capacitor ripple voltage are maximum? Then if it is asked, delta VC is maximum at duty cycle of, if it is asked, differentiate delta VC with respect to D equal to 0. Then you get D equal to 0.5. Then what is delta VC max? At D equal to 0.5, delta VC is maximum. Then what is the delta VC max? Equal to, you substitute D equal to 0.5 here. D equal to 0.5, you substitute 0.5 into 0.5, 0.25. 0.25 written as 1 by 4. 1 by 4. VDC by 32 LC F square. This is the maximum value of delta V. Yes. What is the peak to peak capacitor ripple voltage? This one. What is the maximum value of capacitor ripple voltage? VDC by 32 LC F square. This is 8th parameter. Now we want to calculate 9th one is critical inductance you want to calculate. What is the critical inductance? Understood or not? You do this. What is critical inductance? Critical inductance. What do you mean by critical inductance? This is 9th one. Critical inductance. Yes. How to define critical inductance means? For example, let us consider inductor current waveform. This is minimum and this is maximum. This is average value. We are getting the wave shape like this. Okay. This is IL minima. This inductor current waveform explaining. This is IL max. IL max. This is IL average. This is dt and this one is T. Again, inductor storing the energy. this waveform here. On time inductor storing the energy, off time inductor releasing the energy. In one time period, without current 0, we are supplying the current to the load, then it is nothing but a continuous mode. Tell. For example, let us assume that this is for 4 millihenry. For inductance of 4 millihenry, this is the current waveform, this is the continuous mode. Now what I am doing? We are reducing the inductance. If you reduce the inductance, then what about the current? If you reduce the inductance, then we can get the wave shape like this. Can get the wave shape like this. Then again we can reduce. This is for 3 millihenry. Again we can reduce the inductance. We get the wave shape like this. Let this is for 2 millihenry. Again we can get the reduce the inductance. Reduce the inductance. Let this is for 1 millihenry. Again we reduce the inductance. Let this is for 0.5 millihenry. For different values of inductance, how we can expect the waveform. See the difference here. For 3 millihenry, still the current is in continuous mode. For 2 millihenry also, still for 2 millihenry. This is for 2 millihenry. This is for 2 millihenry. This value is for 2 millihenry. Still the current is in continuous mode. Understood or not? You want clear waveform means? Listen please. What I am telling, this is the inductor current waveform. This is inductor current waveform. This is IL average. On time, off time. This is which one? IL max. This is which one? IL min. This is dt. This is t. Get the wave shape like. Let this is the waveform. Is a continuous current. For inductance of 4 millihenry, we are getting this one. This is continuous. Now what I am doing? I continuously reducing the inductance. When I reduce the inductance, then wave shape will be changes like this. Let this is for 3 millihenry. Again I am reducing. Let this is for 2 millihenry. Again I am reducing the inductance. This is for 1 millihenry. Again I am reducing the inductance. This is for 0.5 millihenry. Okay. Still the current is continuous. This also continuous. But this see, for this also continuous, but current is 0. Then this is for just to continuous. Just to continuous. And this is for discontinuous. Because why discontinuous means? We can reduce the inductance for very small value. Before completing one time period, current is 0. Then it is nothing but a discontinuous mode. That means, here we want to define critical inductance. What do you mean by critical inductance means? The minimum value of inductance for which current is just continuous is called critical inductance. If you select the inductance is less than the critical inductance, this is critical inductance. This is the critical inductance. If you select the inductance is less than the critical inductance, it is the discontinuous mode. If you select the inductance is greater than that inductance, then it is a continuous mode. That means, what do you mean by critical inductance? The minimum value of inductance. Note on this. The minimum value of inductance. The minimum value of inductance for which current is just continuous. current is just continuous is called critical inductance. Continuous is called critical inductance. Critical inductance. The minimum value of inductance for which current is just continuous. In this example, 1 millihenry is the critical inductance. That means how to calculate critical inductance? For critical inductance, what is IL minima? At critical inductance, IL minima falls to 0. IL minima equal to 0. Apply this condition to calculate critical inductance. What is IL minima, you tell me? IL minima equal to 0. IL minima is IL minus delta IL by 2 equal to 0. But in the case of buck converter, IL is nothing but I0. I0 minus delta IL by 2 equal to 0. Okay. In IL equal to I0. I0 minus. Why I taken IL minima? At critical inductance, IL minima falls to 0. IL minima falls to 0. But this is IL maxima. IL maxima is not falls to 0. Understood? Then I0 minus delta IL by 2 equal to 0. If I0 minus delta IL by 2 is 0 means, now tell me, what is I0 equal to from that? I0 equal to delta IL by 2. How to write I0 equal to V0 by R? That is delta IL by 2. What is V0 you write? dVdC. dVdC by R. What is delta L? D into 1 minus D into VDC by FL, that is 2FL. Okay. Then VDC cancel, DD cancel. But you want inductance now? This inductance is called critical inductance. Then R into 1 minus D by 2F. This inductance is called critical inductance. The value of critical inductance equal to R into 1 minus D by 2F. Important formula. This is 9th parameter. Now down quick. The value of critical inductance equal to R into 1 minus D by 2F. Corresponding to this is critical inductance value. Critical inductance value. Corresponding to critical inductance, this resistance is called critical capacitance. Sorry, critical resistance. Corresponding to critical inductance, this resistance is called critical resistance. Then at just continuous, how to calculate duty cycle? Then shall you write like this? At just continuous, L into 2F by R equal to 1 minus D. Shall you write like this? 2L by RT is equal to 1 minus D. Then what is D equal to? 1 plus 2L by RT. Or you take, this is the duty cycle at, this is 1 minus 2L by RT. Duty cycle at boundary or just to continue. Why I am telling that boundary means this is the boundary between continuous and discontinuous. This is the boundary between continuous and discontinuous. Above this is the boundary between continuous and above this continuous. Below this discontinuous. That's why it is the boundary between. At boundary condition, what is the duty cycle? 1 minus 2L by RT. This L is nothing but a LC. At boundary condition, the duty cycle equal to 1 minus 2L by RT. Okay. Mainly remember this formula. Critical inductance. This is 9th parameter. Quick note. One more parameter you want to calculate. 10th one, critical capacitance. 10th one is critical capacitance. How to calculate critical capacitance? Critical capacitance. How to calculate critical capacitance? The definition of critical capacitance is also same. The minimum value of capacitance for which the peak to peak capacitor ripple voltages are, that is the minimum value of capacitance for which capacitor voltage is just continuous. The capacitor voltage is just continuous. This is minimum value of capacitance for which the capacitor voltage peak to peak or capacitor voltage is just continuous, where current is just continuous, but here voltage is just continuous. That means at just continuous, what is the condition, you tell me? At just continuous, what is VC minima equal to 0? VC minima, where IL minima, but here VC minima. How to define VC minima? VC minima is nothing but a VC plus, that is IL plus, here VC plus, voltage across the capacitor, VC plus, delta VC minus, delta VC by 2 equal to 0. Similar to inductor. But voltage across the capacitor is nothing but a capacitor is connected across the load now. Across the load capacitor is connected. That's the voltage across the capacitor is nothing but a voltage across the load. Then V0 minus delta VC by 2 equal to 0. Then what is V0 equal to? Delta VC by 2. What is V0? dVdC. What is delta VC, you tell me? Delta VC we calculated. D into 1 minus D into VDC by 8 LC F square into 2. Then VDC cancel. DD cancel. Then what is critical value of capacitance? CC equal to 1 minus D by 16 LF square. The critical value of capacitance CC equal to 1 minus D by 16 LF square. This is important. Corresponding to critical capacitance, this you take the critical inductance, you substitute critical inductance here, you simplify that, we get one more formula also. That is also correct. By substituting critical inductance here, we can get another formula for critical capacitance. That I am not giving. If you want me, you substitute the critical inductance here. If critical inductance is substituted here, then 1 minus D is cancel, R by 2F, 2 cancel, then 8 LF. That means what you get? 1 by R by 8 LF we can get. Okay, that also we can do that one. If you want one more formula, means to substitute that critical inductance here, we can get one more formula. Okay, this is the calculation of various parameters in the case of buck regulator or step down chopper. All these 10 parameters I calculated. Okay, what is the analysis of buck regulator or step down chopper? But all these parameters I calculated in which mode of operation? Yes, continuous mode of operation. Now I want to give one or two formulas with respect to discontinuous mode of operation. Okay, now let's see. Okay. Analysis in discontinuous mode. Analysis in discontinuous mode. What is the analysis of buck regulator in discontinuous mode? Can you tell me what is the discontinuous mode? Yes. Before completing one time period, if the current falls to 0, then it is nothing but a discontinuous mode. Here I am drawing the inductor current. I am drawing the inductor current before completing one time period. Then for discontinuous mode, you take the current is from 0 before completing one time period. Then this is dt. let this is beta t, but this is t. Before completing one time period, current is falls to 0. This is IL max. But what is IL minima? This is IL waveform, inductor current waveform. Okay. Before completing one time period, this is dt, this is beta t. Before this is beta is the fraction of duty cycle at which current is 0. At beta t, IL minima equal to 0. That means in discontinuous mode, what is delta IL, you tell me, in discontinuous mode? This is nothing but a discontinuous mode. What is delta IL, peak to peak ripple current? Delta IL is nothing but a IL max. Can I accept this? Because IL minima is 0 now. Delta IL is nothing but a IL max. Delta IL is nothing but a IL max. Now, according to volt second balance, using volt second balance. If you use volt second balance means voltage across the inductor during on time. What is the voltage across the inductor during on time? VDC minus V0 into this formula you already know. Voltage across VL, if you want to write, that means VL on into T on plus VL off into T off is equal to 0. Okay, tell me, what is VL on? VDC minus V0. T on is nothing but a dt. What is VL off? Minus V0. But T off is not 1 minus d into T. Why it is not T off is 1 minus d into T? If you take up to T, then it is 1 minus d into T. This is T on. And this only the T off. Then can you find what is T off equal to? This is dt. This is beta t. What is T off equal to? This is from this point to this point is beta t. And this is which one? dt. Sorry. Yes. This is beta t. This is dt. Then what is T off? You tell me. T off equal to what you can calculate? Beta t minus dt. That is beta minus d into t. Beta is the fraction. Okay. At which fraction of duty cycle at which current is 0. This is, in this case, T off is not 1 minus d into t. T off equal to beta minus d into t. That is substitute here. Beta minus d into t is equal to 0. Shall you write like this? VDC minus V0 by V0 equal to beta minus d by d. What is VDC by V0 you write? Then VDC by V0 minus 1 equal to beta minus d by d. Then what is VDC by V0? VDC by V0 equal to beta minus d by d plus 1, that equal to beta by d. Then what is V0 equal to dVDC by beta. See the difference. This is average output voltage in which mode? Discontinuous mode. Average output voltage in discontinuous mode. V0 equal to dVDC by beta. Then this is average output voltage in discontinuous mode. Clear? Then what is the average output voltage in discontinuous mode? Equal to average output voltage in discontinuous mode equal to average output voltage in discontinuous mode equal to V0 in discontinuous mode equal to, that is dVDC by beta. You take average output voltage in continuous mode dVDC. See the difference. For example, if let us assume that this is V0 in discontinuous mode, this is V0 in continuous mode. For example, this is on time, this is beta. If you take D is, for example, you take D is 25%, beta is 40% you take, beta is 40%. or this you take 20%. D is 20%, this is 40%. Then you substitute here 0.2 VDC. This is 0.2 by D is 0.2, beta is 0.2 by 0.4. 0.2 by 0.4 means 2 by 4, 1 by 2, 0.5 VDC. Understood or not? Here we can get D is 20%. For example, D 20%, beta 40% if you take, then what is V0 in discontinuous mode? 0.5 VDC you can get. What is V0 in continuous mode? 0.2 VDC you can get. Therefore, V0 in discontinuous mode always greater than V0 in continuous mode. The average output voltage in discontinuous mode is greater than average output voltage in continuous mode. These observations are important with respect to discontinuous. What is the formula in discontinuous mode that you remember? What is delta IL in discontinuous mode that you remember? Okay. Okay. Then we can do any analysis. You apply current second balance here. If you apply ampere second balance theory, then you can get the expression for average inductor. Then remaining analysis same. Only difference is here. T of you don't take 1 minus D into T. You take beta minus D into T. Remaining analysis in the same whatever the analysis I done. In the same analysis you substitute T of is beta minus D into T. Then we can get remaining formula. But here I am giving only two formulas. Clear? Okay. Concentrate. Easy to remember. This is dVdC by beta. If beta is 1, then it is continuous mode. If it is beta, it is a discontinuous. Okay, that you concentrate. Yes. Then final summary I am giving here for quick reference. You write some summary formula. This is summary with respect to buck regulator. Step down chopper or buck regulator. Step down chopper or buck regulator. Buck regulator summary. What is average output voltage? Average output voltage. Average output voltage V0 equal to dVdC, or duty cycle is also written as T on by T into VDC, or it is also written as T on into F into VDC. This is any formula you can expect. This is one formula where F is the switching frequency. Sir, input is DC where we are getting frequency. It is not a supply frequency. It is a switching frequency. Okay. Next. What is I0? I0 equal to V0 by R. Then I0 equal to V0 minus E by R. This is for which load? R comma RL. This is which load? R comma RE. Okay. Quick. Remaining. What is V0 RMS? V0 RMS equal to root D VDC. What is the form factor equal to? 1 by root D. Then what is the ripple factor equal to? Square root of 1 minus D by D. Next. IL average equal to, that is IL equal to I0. IL average equal to IL equal to I0. Third one. Shall we write what is delta or what is delta IL? Delta IL equal to peak inductor ripple current. Peak to peak inductor ripple current. Inductor ripple current. inductor ripple current. How much you tell me? That is D into 1 minus D into 1 minus D into VDC by FL. Peak to peak inductor ripple current. Then what is the average source current? Average source current equal to D into I naught. That is D into IL. Because I naught equal to IL here. Average source current. Fifth one. What is IL minima? IL minima equal to IL minus delta IL by 2. That is I naught minus delta IL by 2. What is IL max? IL max equal to IL plus delta IL by 2. That equal to I naught plus delta IL by 2. This is maximum inductor current, minimum inductor current. Sixth one. What is ISW average? ISW average equal to average switch current we are getting. What is ISW average we calculated? DI naught. What is ISW RMS we calculated? Root DI naught. What is peak value of switch current we calculated? IL max. Then what is the peak voltage across the switch we are getting? VDC. This is sixth one. Okay. Summary I am giving here. What is the seventh one? Seventh parameter we calculated. You tell me. Peak to peak capacitor ripple voltage. Peak to peak capacitor ripple voltage. D into 1 minus D into VDC by 8 LC. Before that, delta IL you calculate na. This is peak to peak inductor ripple current. At D equal to 0.5. Delta IL equal to delta IL max. Delta IL max. What is the delta IL max equal to? Delta IL max equal to VDC by 4FL. This we calculated. VDC by 4FL. Then what is the peak to peak capacitor ripple voltage? 8 LC F square. 8 LC F square. At D equal to 0.5. Delta VC equal to delta VC max. Then what is delta VC max equal to? Delta VDC by 32 LCF square. Then eighth one. I forget one form. 1, 2, 3, 4, 5, 6, 7, 8. Then what is the critical inductance? What is the critical capacitance? IL average we calculated. Delta IL I defined. IS average. Freewheeling diode current. What is IFD average equal to? I naught IL into 1 minus D. That equal to I naught into 1 minus D. Is correct? What is IFD RMS equal to? IFD RMS equal to IL into square root of 1 minus D. But IL equal to I naught here. Root of 1 minus D. Ninth one. What is the critical inductance equal to? R into 1 minus D by 2F. What is the critical capacitance equal to? CC equal to 1 minus D by 16 LF square. 1 minus D by 16 LF square. Critical capacitance. Next, 11th one. In discontinuous mode. What is delta IL equal to? IL max. IL max. Then what is V0 in discontinuous mode equal to? That is dVdC by beta. dVdC by beta. Then V0 in discontinuous mode is greater than V0 under continuous mode. Okay. This is 11th observation. Okay. You write as a note. First one. If L given greater than LC, then it is a continuous mode. If L given less than LC, critical inductance. LC is nothing but a critical inductance. Then it is which mode? Discontinuous. This is one way to analyze. Okay. Or otherwise, second one. You write at boundary. What is the condition at boundary? Critical inductance na L equal to R into 1 minus D by 2F. Shall you write like this? 2F. That is 2L by RT equal to 1 minus D. Okay. If 2L by RT is greater than 1 minus D. If 2L by RT equal to 1 minus D, then this is which one? Just to continuous. Just to continuous. Just to continuous. 2L by RT greater than 1 minus D, continuous mode. 2L by RT less than 1 minus D, this is discontinuous. Like this also we can analyze. How to analyze continuous mode and discontinuous mode? 2L by RT equal to 1 minus D, just to continuous. 2L by RT greater than 1 minus D, continuous mode. 2L by RT less than, this is discontinuous mode. Where 2L by RT is called conduction parameter. Conduction parameter. This is called conduction parameter. 1 minus D is called critical. This is a continuous conduction parameter. 2L by RT is taken as a conduction. Then critical value of conduction parameter. Critical value of conduction parameter. Different names I am giving here only. Okay. Here you take 2L by RT is conduction parameter. 1 minus D is critical value of conduction parameter. If conduction parameter greater than critical value of conduction parameter, then you take which mode? Discontinuous. Then it is take discontinuous mode. It is discontinuous. One more last note you note down. For lossless chopper, then Ri equal to R by D. This is effective value of input resistance. Effective value of input resistance. Input resistance. You can equate input power equal to output power. Input power means Vs square by Ri. Output power equal to V naught RMS square by R. Where Ri equal to effective value, where R equal to load resistance. Okay, this about in detail about what exactly buck converter or step down chopper.